Hey. Um, Third exam, right? Yeah. All right. So first and foremost, the rumors are going around. So when I went home last week, I was like, "Oh, when's the next exam?" And long story short, if you saw the Blackboard or email, I said it's this Wednesday. So bottom line up front, no. As I said on day one, the exam dates are in the syllabus, which stand corrected is April 2nd. Um, the confusion, not that you care, but I opened up an old syllabus from an old Math 2103 course. And so I was like, oh, I was looking at the date and I was like, March 26th. I was like, that's next week. Uh-oh. And that also makes sense. Here's another thing. It will not be any of the review topics that I had previously said. Although if you put time into that, spoiler alert, those are the topics that'll be on the final. So good thing. Anyways, not time wasted, but it will strictly be on all trigs. So what we started right before April, not April vacation, spring break, but mostly since we've been back. So what we cover this week, and I don't think there'll be much that rolls into Monday. So Monday will mostly be a review day on trig stuff. All right. So bottom line up front, sorry about the confusion. That's why I didn't even bother sending up a secondary email. Didn't respond back. I apologize. Because I would address it here. So sticking to the original exam dates in the syllabus that came out April 2nd, exam 3, and it will strictly be on trigonometry, no review topics. All right, off we go. Other than that, tonight we're going to talk about the unit circles. We didn't get to that yet, right? I haven't passed one of these out to everyone yet. Nope. Okay. So we'll do that tonight for sure. Answer a couple questions, and off we go. What remains in trigonometry after tonight is really looking at some graphs. So next class, which is on Wednesday, we're going to look at this graphs of sine and cosine, and potentially, as I said, might carry over into Monday a tiny bit. But that's what's left in our trig topic here. If you haven't had trig formally as a course, this is the trigonometry you need to be successful in applied calculus. If you had a formal trig course, or if you decide to take one, you would go more in depth with a lot of what we did here. I mean, we got the backbone, we got the foundations. We just don't really look at the extensions. For instance, we're not going to look at the graphs of all 6 trig functions. We're only going to look at the main 2, and I'll leave it at that. But tonight, all about this thing called the unit circle. So right off the bat, welcome back. Here we go. Unit means 1. So the unit circle means we have a circle whose radius is 1. But it has additional context. It also is a circle that's on the coordinate plane. So we have to put that center somewhere. What a good choice. Let's define it to be at the origin. Since it's a graph on the coordinate plane, it turns out there's an equation that builds it. And that equation is x squared plus y squared equals 1. And this last one, I'll give a moment for you to copy it before reading it at you. Come on, go away. What? Okay. That's kind of a weak circle. We'll give it one more shot there. That's weaker. Let me try to freehand this one more time. Oh, that one came out really good. Nah, I just freehand that. What are you talking about? All right. Yeah, that's not. We're gonna let it go. All right. There's like only so much I can do here. So 0-0 right there. It's not actually on the circle. It's the center of the circle. And if we went from the center to any point on the circle, it has a radius of 1. That's really it. The main points about the unit circle, if you went to Desmos, you typed in x squared plus y squared equals 1, you would absolutely see a circle. Now here's the last one. It says the radian measure of the central angle. So I'm going to erase some of this in here. That's a little too much. So nice and clear. If I was said, hey, this radian measure right here, so if I started here and I rotated to here, that's pi radians. We know that is 180 degrees, half a rotation, pi radians, our previous lesson. Well, it turns out only on the unit circle that this distance along the circle would also be pi units. Those are different labels. One's a rotation. How would I do a half rotation? So if I'm facing this way, that's like a pi rotation, like a 180 degrees. But I mentioned walking around the room last lecture and walking around the state of Rhode Island in a circle. Those are different amounts of steps. One of those I can do in a minute. One of those I'm going to need a year, right? Because it's longer steps. So the rotation is pi. This distance is also pi. That's it. It's kind of a neat outcome. Actually, it's not a neat outcome. It's really stemmed off of what a radian measure is. A good definition that I said to know, not should know, but must know, is theta radians is S over R. But if the radius is 1, there it is. There's the proof. The rotation is equal to the arc length. Only on the unit circle, because R becomes 1. Right? So that's what that last saying is. It's actually nothing we didn't know already. Theta equals S over R, but if R is 1, then theta is equal to S. That's it. Cool. We'll come back to that at some point this evening. For now, we're going to kind of really just work on these well, there's not really much to work on. We're going to use the first 3 points here, first 3 facts. So a question that we should be able to answer just based on this definition is this point 1/2 comma root 3 over 2 on the unit circle? And the answer is, I don't know. How do I figure that out? So use equation. X squared plus y squared must make 1. If you sub in the x and the y and it's true, meaning it makes 1, you're on the unit circle. Otherwise, if you sub in an x and a y and it's not true, you're not on the unit circle. So this is really how you answer that question. So if we sub in x 1/2, square it. If we then sub in the y, root 3 over 2, square it. Does it make 1? Yes. Check on a calculator, check in your brain. Check. That's what you have to do. I'll check with my brain. 1 times 1, 2 times 2 is a 4th. Root 3 times root 3 is 3. 2 times 2 is 4. And I know that 1/4 plus 3/4 does indeed make 1. So the answer is yes. Okay. That's it. Pretty simple question. Just confirming how we use the equation. If it were to be false, we would have said, nope, not on the circle. All right. So suppose we're given an x, but not a y. How many y values are possible? How many solutions are there going to be? And what are they? What's your instinct tell you? How many solutions are there going to be? I'm hearing 1 and I'm hearing 2. It's your instinct, so it's not a wrong answer. It's your instinct. Who said 2? Why do you say 2? Okay, so if you're squaring, like if we go back to this equation, and we're gonna work out the answer in a minute, then when we go to solve something, when we take a square root, we're gonna get 2 solutions. Bingo. Another way to think about it is maybe just watch this part. All right, we're gonna answer it formally. But if I walk not a full unit from the origin, because if I did a full unit, I would have gone too far. So if I go 1/3 and 2/3, so here's x equals 2/3, not a full radius, right? Because the radius is 1. I didn't go a full 1. Now I have a choice to get to the circle. Well, I either have a positive y distance or I have a negative y. But I think we're going to get 2 answers here. Actually, I know we're going to get 2 answers. 1 based on the equation, 2 just based on how a circle kind of has its symmetry. I don't know what else to say there. So let's find those 2 values. Okay, why are you? This was working so nice earlier. There we go. Okay. We turn to our equation. X squared plus y squared equals 1. Sub in the x. Again, you can turn to a calculator to do some of this number crunching, but it turns out it's not really that bad. 2 times 2, 3 times 3, that's called 4/9. So if I subtract that on both sides, one is the same as 2 out of 2, is the same as 3 out of 3, is the same as 9 out of 9. And if you remove 4 out of 9, you have 5 out of 9. Or you got this little tool just to remind us, why not? Calculator, I'll pull it up in a minute. I don't want to waste too much time today. All right. Take a square root. I guess it's going to tell me it's the boss, and we have to do what it says. Done. Yes. Boom. Come on. 1 minus 4/9 is 5/9. All right. So it's almost quicker to do it in my brain because that takes more time. But just showing, use a calculator. Anyhow, take a square root of that. You get the square root of 5 on top of 3 with our plus and minus, right? We solved quadratic equations earlier in this course. When we take a square root, we want to include plus and minus. And there's our two answers. Nothing elegant. It's not like a nice number. If you want to know approximately what it is, so if I ask for the square root of my answer, it's about 0.74 or 0.75. So if we round it a little bit, right? So almost 3/4 the way up the circle. But that's overkill. This is your exact answer. And we want to work in exact form pretty much all night tonight, all right? So this is a completely good answer. And it makes sense to what I said before, the way a circle behaves. This would be a radius of 1. I don't want to go that far. It says if x is 2/3, so here's 2/3, then there's an output at √5/3, and there's also an output at -√5/3. Kind of makes sense now? Why there's two answers? All right, so we are about to complete a standard unit circle. Let me give everyone a copy of this. We're going to start on this side and then kind of work front and back. You're welcome. You're welcome. You're welcome. You're welcome. You're welcome. All right. So find the side that looks like this. We're actually going to build it mathematically. What does that mean? Like, I'm going to explain all the details. It's not actually as bad as you think, right? Maybe you're thinking, oh, this is going to be nasty. No, it's actually building the idea, not just telling you the facts. If I wanted to go to the facts, I'd just say, copy this and know and memorize this. But I want to build these facts. So I've highlighted a triangle because we've previously talked about triangles. We've previously talked about, and I want to start with this guy, the 45-degree right triangle. So we're focusing just on what's shaded right there. Okay. And in a 45-degree triangle, 45, 45, 90, I've asked you to remember that what are the leg values? What are the two, like what's the base and the height? 1 and 1. And then what's the hypotenuse? √2. I have a small issue. Please continue to remember that, but we're going to fix the issue. The small issue is I want to slide this like right there. But how long is this hypotenuse? 1. They're not in agreement. What would I do to square root of 2 to make it become 1? I would divide it by itself. So we're going to take all these values and divide it by √2. In high school geometry, this is called similar figures. When you're taking an object and just like scaling it up, like a photocopy of a picture, you might want to, your wedding picture, you want to get it enlarged. You're just scaling it up. Or maybe you want little wallet size picture of your prom dates, things like that. It's just called similar. So we're allowed to do this as a legal move. This now becomes 1. And so this right here is 1 over root 2 and 1 over root 2. Next conversation I'm going to have with us. Rationalize. I believe I briefly talked about it, but now it's nice and clear. This is a fine answer, right? Calculus doesn't have a problem with that, but at this level, plus there's a pattern that's going to emerge in a moment. We say we don't want square roots in the denominator. So it's a quick fix. You simply just multiply top and bottom by whatever you have. And it becomes square root of 2 over 2. So a lot just happened there, but I promise it's all coming together right now. Think of your 45, 45, 90 triangle. Good. The hypotenuse, I want to slide it over here. That's like what I'm imagining, but the hypotenuse wouldn't fit. So we had to kind of scale it down. Now that it's 1, it's like, fitting right there perfectly. Cool. These values, I purposely wanted you to recognize 1 over square root of 2, legit. However, a lot of times, more often, I'd say like 60% of the times to 75% of the times, your future professor, online textbooks are going to write this. And you're going to be like, where did that come from? Literally something called rationalizing the denominator. Just multiply top and bottom by whatever number you have there, root 2. At the end of the day, back to the story. What's this ordered pair? And if I move to the right and up, what is that ordered pair? Oops. Come on, pen. There we go. Well, isn't it 1 over root 2 to the right and 1 over root 2 up? And 1 over root 2 is the same as this thing right here. So the ordered pair is root 2 over 2, comma, root 2 over 2. Let's make it easier for 1 second. It's just the symbols that are scaring you. What if I said this was 1 right here? And this was 1. Then you would tell me, Professor, that ordered pair is 1, comma, 1. Or if I said this was, I can do it this way so you can really see it. Suppose I say this is, pretend that's not there. This is 100, and this is 100. What's that ordered pair? You would say 100, comma, 100. Over 100, up 100. So it's just the symbols that's hurting your mind. Okay, following that logic, it's 1 over root 2, comma, 1 over root 2, but we typically write it like this, that's all. Make a little more sense? Neat. What have I done with this triangle over here? What do you think I've done? What's that? I'm hearing a lot of things. I reflected it over the y-axis. Does that mean the height and the width are going to change at all? No, it's you reflect this, nothing changes except like its orientation, like where it's located. But in terms of like height and width and things, no. But we're on a coordinate plane. Keep that in mind. We're on the coordinate plane. So what's this? Oh, come on, stop doing that. What is this ordered pair? Well, what's one thing that's same about the triangle here? It has the same height. Perfect word. Which one of these numbers is the height? Well, that's kind of, is the x or the y the height? Because I need to know. Okay, that was a terrible joke. But the y coordinate stays the same. It's literally the same height. And the base is the same except for direction. This is 0, 0. This is negative root 2 over 2 and positive root 2 over 2. Now you'll super impress me. You do every day. You really do. But you'll super impress me if you think about this first before answering. What, we'll do degrees, is that rotation? Remember, we reflected the gray triangle. What is that rotation? That standard position. I started here and rotated there. 135 is 100% correct. What I'd like us to do is go to this intense looking picture. And we're going to say, let's see, what do the directions say? Place the degree angle on each dashed line. So 45 degrees literally cuts quadrant 1 right in the middle. So 45 degrees is right in the middle. We're going to write 45 degrees right here. And we're going to say this is root 2 over 2, comma, root 2 over 2. And then we're going to go to quadrant. What quadrant is this over here? 2. Right in the middle. We're using this idea of a reflected triangle. We're going to write negative root 2 over 2, root 2 over 2. However, we're going to call that 135 degrees. While we're here, let's just bang out the radian measure. Hopefully you've started practicing these common angles. But if not, everything you need to know is going to be on this one thing. All the famous landmark things you need to know by heart are going to be right here. Everything. Degrees, the points, and the equivalent radian measure. This is a calzone. It was the silly phrase I recently talked about. What slice of the calzone is this? How much does that make up? 1/4. So let's not call it a calzone. Half a rotation is pi. So its radian measure is pi over 4. And this would be 1/4, 2/4, and rotating all the way here is 3/4, 3 pi over 4. Maybe you know where we're going with this. What if I'm here and I start thinking about, well, let's take that triangle and rotate it down to quadrant 3. What's going to stay the same? The x-coordinate. What's going to almost stay the same except for its signed value? The y-coordinate, because now we're also traveling down. So we're going to get a negative root 2 over 2, comma, negative root 2 over 2. That's too bad. That just closed on me. Yeah, it did. Some of my stuff got rid of. That's all right. We'll pick up from here. Negative root 2 over 2. Negative root 2 over 2. What's that rotation? 225. And let's, while we're here, what's this point going to be? Positive or negative x? Positive or negative y? We're already speeding this up. Here's the thinking part. It's not impossible. What is that rotation? 315. All the way around would have been 360, but that 45 degree, what word is that called? The blank angle starts with an R. Did it in a homework. Reference angle. So that's a 45 degree reference angle. That's a 45 degree. That's a 45 degree. That's a 45 degree reference angle. But the actual standard position vocab there is 315 degrees. So let's add that to the big guy right here. Negative root 2 over 2. Negative root 2 over 2 corresponds to a 225 degree rotation, which is not 1 pi over 4, it's not 2 pi over 4, it's not 3 pi over 4, it's not 4 out of 4, it's 5 pi out of 4. Why stop there? 6 out of 4, and then right here would be 7 pi out of 4 radians, 315 degrees, positive root 2 over 2, negative root 2 over 2. And we've now completed a portion of the unit circle. Yeah, I did. And there's part of our unit circle. Cool. Kind of cool things. I really like trigonometry because we built the 45, 45, 90 degree triangle by taking half a square and just using human instinct. And now we're just kind of moving it and reflecting it along a circle to get these points. You guys told me how to convert degrees to radians. You literally came up with the definition of the human way. So I just want you to appreciate this is all you. All right, this is your building these facts. Pretty sweet. You also built, with my guidance, but I'm giving you the credit, half an equilateral triangle. We're going to end up doing both. Let's go with 30 degrees. Smallest angle is 30 degrees. You put the smallest number of 1. Largest angle is 90 degrees. You put 2. A 1, a 2, a 1, 2, root 3. That's the facts you should know. That's the 30, 60, 90 triangle. I want to slide that green triangle into this position. I have a problem. The hypotenuse is too long. Fix the problem. Scale it down. Divide by 2. But we divide this by 2, and we divide this by 2. Now the hypotenuse is 1, which we want it to be because this is a unit circle. And we don't need to rationalize anything. This is going to be root 3 over 2, 1/2. So putting it all together, root 3 over 2, 1/2. And I bet we can do this in literally half the time. Reflect it over negative x, positive y. Reflect it downwards, negative x, negative y. Bring it to quadrant 4, positive x, negative y. Independently for 1 minute, what's that angle? What's that angle? And what's that angle? Starting from 0. And if you're like, how are my classmates figuring this out? You might want to look up here. Everyone should know what I just did is half a circle, 180 degrees. That's too much. I went too far. I have to back up 30 degrees. So 180 take away 30 is what I asked. 180 take away 30 is 150 degrees. We'll come back to that in just a minute. 180 plus 30 more. 180 plus 30 more. Either do it in your brain or do it on the calculator. That's going to be 210. And then if you go all the way around and then say, oops, I got to go backwards 30, 360 minus 30 is 330. Let's put it on the unit circle. $30 degrees is 1/3 of 90. So that's right here. It's less than half. How much of the calzone does that make up? Well, that's 1/3, that's 2/3, that's 3/3, 4/3, 5/3. This would be 6 out of 6. So this is, why did I say thirds? 6. This is 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. That was weird. So this is pi over 6. Pi over 6 radians. And at the end of the last class, I did say you should know those. So after tonight, I expect us that we're working, not just the night before the exam, but that we, like tonight, you start making index cards. Or you print out a blank unit circle at home or in the library. Go to the library before you leave, type in Google, blank unit circle, print 15 copies, and start doing one of these or 2 of these a day. Anyways, talk about that later. 30, pi over 6, those are your rotations. We're going to associate it with that point. We're going to reflect it over here. Negative root 3 over 2, positive 1/2. 150 is the degree measure. And again, trying to give you some tips by saying it over and over again. This is telling us how we're cutting the calzones. This is 1 out of 6. So all of it is 6 out of 6. Remove 1. 5 pi out of 6. Go down to quadrant 3. 180, 30 more is 210. Add another 6 becomes 7 pi out of 6. change the signs on the X and the Y from original, right? So now we just have the opposites on both X and Y. And lastly, in quadrant 4, all the way around would be 360. So 30 less is 330. 6 out of 6 all the way around would be 12 out of 6, called 2 pi. But we're short 1, so this is 11 pi out of 6. X is positive, Y is negative. Cool. All right. One more to go. And then end with the easiest ones. I hope you start to find all of these easy. Let's go back to that 30, 60, 90 triangle. Except I don't want 30 as my reference angle. I want 30 on the base. I want 60 on the base. So I'll use purple. This is 60. So my smallest side is actually right here. Just reminding you, here's the 30, opposite side, smallest number. 1, 2, a 1, 2, a root 3. Speeding up the story even faster now. We're going to slide that over there. Bro, it's too big, so we're going to divide it by 2. Now it's 1. Divide this by 2, divide this by 2. This is 1/2. This is root 3 over 2. That's 60. Meaning the x-coordinate is 1/2, and this is root 3 over 2. If you're feeling brave, I'm going to say nothing for 2 minutes starting in 5 seconds. Label the point, that one, this one, and the angles. By the way, this is called active learning. You're actively learning. You're not listening to me. You're now participating. "30 more seconds. Some of us are already done. Didn't even need the 2 minutes. Not a race, though. It's not a race. Actively think. But before you mark up your unit circle, if you're doing it because you're super confident, cool. I just want to, if you made a mistake here, that's okay. 15 more seconds. And there's our 2 minutes. Okay. So I'll erase some of this. That was there just to kind of remind you what you needed to find. That's 180. Everyone on the earth should know this, but you went too far. So subtract 60. What is that called? 120. This is 180 and go 60 more. How much is that? This is 360, but you went too far. Go backward 60. 300. Great job. $60 degrees. 1/2 root 3 over 2. How much of the calzone is that? 1/3, because there's 2/3, and that would be your 3/3. So pi over 3, radian measure. And my goal for you tonight, it's not official, I can't actually check. Learn 3 things tonight really well. 1, 2, 3, like this. Learn it like you can't unlearn it. And then tomorrow night, that won't even feel like work. You start back here and you bang out that side. And then in no time, you'll have this completely memorized. And the more you write it out, you're gonna want to stop writing it. You're gonna say, I know it in my head. And I would be like, hell yeah, that's awesome. I don't care though. I'm always gonna give you a blank unit circle on future assessment. I'll talk about assessment purposes right now. Let's just focus on like learning this really, really well. Okay, take these points. This is negative. This guy's positive. 2 pi out of 3 is the radian measure. And you guys correctly told me 120 degrees. Down here in quadrant 3, 240 is the degree measure. 3 out of 3 would be the whole calzone. 1 more is 4 pi out of 3. Going all the way now to quadrant 4. 1 out of 3, 2 out of 3, 3 out of 3, 4 out of 3, 5 out of 5 out of 3. Oops. Which is 300 degrees. And we're going to associate it with a positive and then a negative. That's the hard ones. There's a couple easy things left. What is no rotation? 0 degrees. Also 0 radians. What is this ordered pair? This is called center. This is called a point on the circle. 1, 0, because the radius is 1. 90 degrees. Half a calzone. Half pi. Pi over 2. 0, 1. 180 degrees. I call that the capital city. That's the biggest one. Biggest fact of trigonometry. 180 degrees is pi radians. And that it now has, we sort of associate it with this point, -1, 0. 270 degrees, 3/2 or 3 pi over 2 radians. Zero, -1. And last but not least, a full rotation is called 2 pi radians. And you'd be back in coterminal position as doing nothing at all. And we've now completed the unit circle. Yeah! Woo! What's the big deal? It's not that big. Well, it's actually kind of neat. Right? I think it's fun. As I said, I think it's personally neat. If you truly have been kind of like following along, you built the definition of radians using my alien math. You helped tell me what's true about 45-45, 90-degree triangles, and 30-60-90 triangles. And so these are the outcomes of your discoveries. Pretty neat. All right. What do the directions say? Practice filling this in. So I promise you, if you say blank unit circle, you might find this exact one, or you'll find some teachers have put 4 on one sheet. You're going to find a lot of different, like hundreds and hundreds of them. And one thing you can absolutely do, like I said, go to the library, print out 10 copies, and start practicing one every day. If nothing else, you can sketch this yourself, right, on scratch paper. You have a job or you're babysitting, I encourage start with quadrant 1 because that's really the foundation. Everything else is like a reflection and just practice. Know the degree, the radians, and the points. On next week's test, the first question will be no calculators, no nothing. You have 10 minutes tops, because after 10 minutes, it's like, all right, move on. But within 10 minutes, complete that accuracy. So it's not the whole test, but it will be the first thing. So the first thing is going to be just like that. Put your name on it, blank unit circle, complete it. And only on the next test will it be graded. After that, like for the final exam, you should know it. It won't be a question on the test, but you'll want to know that. Right. All right. So that's it. Good night. Go home. No, just kidding. It's only half the lesson. We're halfway done. Unit circle. Know that it's 0, 0. Its radius is 1. Know its equation. Here's some questions that you can answer with the unit circle. And then the common landmark famous angles, you should be able to create one of them. All right. A little bit of writing for a moment, but this is really the second part of tonight's lesson. So I introduced you to the sine, cosine, tangent, SOHCAHTOA using right triangles. We started right before spring break, but I came back and reminded us SOHCAHTOA. And that's a perfect definition for right triangles. But you won't find 200 degrees in a right triangle. You won't find 300 degrees in a right triangle. It is impossible. So we're going to extend, and by the way, strengthen the definitions of sine, cosine, and tangent. I'm going to make a connection in just a few minutes. But stronger than opposite over hypotenuse and adjacent over hypotenuse and all those things are the following definitions. I'll let you copy for 2 minutes because I know you can't, our brains aren't designed to multitask. So give me a moment to copy down and then we'll talk out some of what we're seeing. All right, should be kind of gauging the class. Some of us are done, just kind of finishing up, I think, at this point. So let me digest or dissect so you can digest everything that's here. It turns out knowing SOHCAHTOA is right here. Because I'm going to ask, does anyone see a right triangle on this board? And you're going to say, yes, it's right there. So if I say, look at theta, what is opposite theta? You're going to tell me why. And then if I say, awesome, now tell me what is the hypotenuse. You're going to say r. The radius of a circle is acting like the hypotenuse. Cool. So if I say, all right, what's your right triangle definition of sine? You would say opposite over hypotenuse, y over r in this diagram. Because our right triangle is now on the coordinate plane. And if you see that connection, this doesn't feel like 6 new things. It really just sounds like this is x. That's how you plot points. You start at the origin and you go x and you go y and you see a right triangle and you could build those every single time. Let me just highlight this so it's nice and clean as well, at least for my sake. And if you go back and watch this video, you'll see it that way too. If I asked you what is adjacent to theta, you would say x. And if I say, all right, what's adjacent over hypotenuse, you'd say x over r, which right here is the cosine. So it's not really a new definition. It's how we label angles when we don't just think about right triangles, but move them into a bigger world of rotations. I'll leave it at that, okay? We can also establish from this picture right here, good old Pythagoras, that x squared plus y squared equals r squared, because you have a right triangle. Everyone learns differently. Some of us won't need to make any more connections. So like now, like for me, once it was explained to me that way, it wasn't initially explained to me this way. Once someone drew this picture, I was like, I don't see this as 6 new facts. I just see it as taking this picture and knowing SOHCAHTOA and the reciprocals. But we all learn differently. For those of us who need to make index cards, add these. Right triangle trig and the stronger, what I'll call X, Y, and R trig for any angle. All right. I only got really one more blurb, and then it's going to be math stuff. So here's the last 2 blurbs. And this time I will talk at the same time. I just said above there, the sine is y over r, and cosine is x over r. But if we're on the unit circle, I want my point to be made here. If we're on the unit circle, these become 1, and we typically simplify things over 1 by not writing them at all. And here comes now the mathematical strength of SOHCAHTOA, all those facts I just said, and what we just built. We're really going to now take the ideas and put them together. Why did we just build that unit circle a few minutes ago? Point number 1, the x coordinate is the cosine. The y coordinate is the sine. Point number 1. Biggest point of the night, right here. And tide is right there. The x coordinate is the cosine. Y coordinate is the sine. So if you have this up here, or you're able to do it from scratch, you can do trigonometry. You can do the trig facts. Because I don't want you to see that yet, even though you're already, if you're writing it, I'm going to erase it in a second. You're going to be, I want you to write it, just not yet. Okay. Next fact. Tangent was y over x, opposite over adjacent. But we just said right here, x can be called cosine and y can be called sine. New fact. Tangent is the same as sine on top of cosine. It is y over x, but since y is sine and x is cosine, it's basically like I'm just substituting in something new. What's that? And it's just the slope of the line. X squared plus y squared is r squared in this picture every single time, but we're on the unit circle, so r becomes 1. X squared plus y squared becomes 1. And furthermore, if we substitute in these two facts again, that x is cosine and y is sine, I probably did it in opposite order, but that's okay. Sine squared plus cosine squared equals 1. And I showed that a few lessons ago called the Pythagorean identity. But now it's just nice to see why this stuff is true. If it's come up in 2 lessons, it must be pretty important. And we're building this stuff. You'll apply it more in calculus, but now we're going to apply it. In just 1 more minute. One final fact. This one's, what the heck is this saying? Well, first of all, we'll write it down. And we're going to write it down correctly because I do have an error. Negative sine. Sine of negative theta is negative sine theta. Cosine of negative theta is positive. All right, super informally, but kind of student language. What is this symbol saying, and how do I need to be able to apply it? It says if you have a negative rotation, whether it's degrees or radians, and we're about to apply this stuff in less than 2 minutes, factor out the negative sign and treat it as if it was a positive rotation. Informally, factor out the -1 and leave it out front. But for cosine, factor out the -1, so usually it means it's out front, and then ditch it. It's just positive cosine. Why does this make sense? We're going to apply all of this, but you have your unit circle in front of you. Sine of -30, by this definition, says take the negative out and just rotate 30. Now, for that to make sense, let's look at that honestly. Negative 30 means rotate clockwise 30 degrees. Okay? So there's my negative 30 degrees. And what's the y coordinate there? Because we said on the unit circle, the sign is the y coordinate. Negative 1/2. It's the same as factoring out the negative 1 and just rotating 30. Sine of 30 is 1/2, but now there's a negative 1 in front of it. It's logical. It's logical thinking as much as mathematical is, but this really is. In other words, alligator mouth. Open 30 in both directions. This is called a negative angle when you open downwards. What's true about the y coordinates? They're opposites. But alligator mouth, open, and it doesn't have to be 30 degrees. Let's go 60. The y coordinates are going to be opposites, but the x, you can kind of just ditch it. They're going to be the same. And that's what it's actually a major useful fact. Earlier in this course, we called this odd and even. If you remember that, we did. What is an odd function? What is an even function? Cosine is even. Sine is odd. We could figure out the rest. It's not important for us. Okay. All right. The rest of tonight is just practice, like homework, some homework questions, things you're going to be asked to do in the homework. First, says find the 6 trig functions for pi over 2. And by the way, I'm just going to change one thing, minor thing. Your homework likes to call this t. I don't know why. So it's really just, it says t. I wish they used theta. Maybe that's why they called it t, for theta. Maybe. I don't know. At the end of the day, it's like, yo, rotate pi over 2. So you pull this thing out and you find pi over 2. And with practice, you should know that that's, bro, look at right at 90 degrees. And we're going to go down the list. Sine of pi over 2 is the y coordinate. Is 1. That's your answer. Cosine of pi over 2 is the x coordinate. 0. That's all you have to do. This is the part to memorize. This is like your multiplication table back in the day. What's 4 times 3? 12. You don't do that anymore. You have it up here. But anyways, that's why I said serving like a multiplication table. Tangent is y divided by x. So we take, or what I said, it's the sine value, 1, over the cosine value. It's sine over cosine. Right? It literally makes sense now. 1 over 0 is a problem. We can't divide by 0. So you're expected to write, or whatever they say, I think it says type in the word undefined, or maybe it's a multiple choice option. But getting undefined values is not unheard of. Sine, cosine, tangent have reciprocals. Cosecant. Oops, I'm sorry. I'll leave the r over y. What's the radius on the unit circle? 1 over the y coordinate. 1 over 1, still 1. By the way, I could have just reciprocated this, which stays right there.
Should we leave the R below?
That's for your reminder. At the end of the day, you need to get the circled answer here. Reminder, secant is r over x. On the unit circle, it's 1 over x. So we'd get 1 over 0. Uh-oh, undefined popped up. If anyone's not following what I'm doing, I'm just remembering what this means. It's a ratio that flips this ratio. I didn't mean to put the r, but since I did, I just live with it, right? So I really just wanted to flip x as 1 over x, but it's all good. You go to your unit circle, and you literally take the x coordinate there, or the y coordinate, or whatever ratio our trig values, whatever ratio we're looking for. Okay. Lastly, cotangent is x over y. 0 on top of 1 is not an issue. That makes 0. Pretty simple. Just be able to find, using your unit circle, the values. Okay. Again, our textbook author likes to call this T. So, whoop-de-doo. At the end of the day, we're going negative 5 pi over 6. Here we go. Sine of negative 5 pi over 6. Hear me out. Factor out the negative 1 and keep it. Got to remember, that's the part you're going to have to study. But for sine, remember alligator mouth, the y coordinates are going to be opposite. This one's up in the sky and this one's down. Those are different heights. That's how I remember it. The y's are not the same. The y's are opposite. Now we look at 5 pi over 6 on our unit circle, or hopefully up here in time. 5 pi out of 6 has a y coordinate of what? Perfect. Carry your negative sign. And answer that. So the negative sign carried over. This block is 1/2. Your final answer is negative 1/2. Cosine of negative 5 pi out of 6 says factor out the negative 1 and ditch it. Must know. But since I just taught it to you, alligator mouth. This right here is the origin. If I were to measure how far my fingers are away, they're the same distance. These are just up. That's a positive y. These are down, negative y. But they're the same distance to the wall, even though I'm opening different directions. So that's the y. I'll stop saying, I'll stop doing it, but for some of us, I wish all of us, not just because I tell you, but it makes sense. We're taking out the negative sign and ditching it. It's the same as cosine of 5 pi out of 6. We go to 5 pi out of 6, and you get negative root 3 over 2. Tangent. I didn't tell you what to do with tangent. Oh, did I? Here we go. I said tangent is the same as sine over cosine. Yes, it's y over x, but here's another way of thinking about it. And this is how you start thinking about more complex things. So we're going to take our answer. Hey, we know what this is. It's -1/2. And we know what this is. It's -√3/2. So we get -1/2 on top of -√3/2. If you have this calculator or a calculator that does fractions, -1/2 on top of -√3. Oh, man, that sucks. And it's going to give you a simplified answer, √3/3. If you don't, then you got a little tiny bit more effort to do. I'm going to multiply top and bottom by 2. Times 2 times 2. Why is that useful? Oh, here it goes. So when you multiply this by 2 over 2, that cancels and that cancels. I cleared the denominators. Negative over negative turns positive. So I did 2 things there. I multiplied by 2 over 2. There it is. It cancels those out. A negative over a negative turns positive. That wasn't the answer that the calculator I recommended for this course gave you. But we rationalize, as I said earlier tonight. And now you have it. So I'll leave it at that. Not going to lie. Does someone who had that calculator maybe have a small advantage? Yeah. But it's not impossible math to do if you don't have it, right? Cool. Cosecant, CSC of -5 pi out of 6. What have we been reviewing tonight? Just reciprocate this answer. Invert it. Secant of -5 pi out of 6. Invert your answer. Oh, SpaghettiOs, we have a square root on the bottom. So multiply by square root of 3 over square root of 3. And lastly, cotangent of -5 pi out of 6. Take our answer, reciprocate it. Oh, SpaghettiOs, but that's okay. You get 3√3 over 3. And wait a minute. Those cancel out, and you're left with √3. It looks insane. I'm totally there. There's pi symbols, there's square root symbols, there's craziness. At the end of the day, it's the basic things. 1, you got to know your unit circle. 2, you got to know what sine, cosine, tangent, and pair them with their reciprocals. Factor out a -1 if there's a negative, and leave it, alligator mouth. Factor out a -1 and ditch it. Same reason, kind of alligator mouth. Sine is different height. Sine is the y value. Cosine is the x. From there, sine over cosine, put in a calculator, or it's not that bad. It happens frequently. The thing is, they're common numbers, so it becomes, by doing it, strengthening. For those who want to know it a little deeper, and you have the calculator as a safety net, hats off to you if you try it without a calculator first. That's what's going to make you a little bit stronger, right? So maybe you take a few examples and say, I'm not going to use my calculator at all. Let me see if I can do strictly mathematical and check with the calculator. Anyways, I'll let it go. We got one more thing to do. 660 degrees. That's not on a unit circle. Obviously, it exceeds 360. It exceeds going around the unit circle once. We'll come back to this in our notes in just a minute, but so that I can be obnoxious, or I say obnoxious, but really just kind of showing you what's going on here. All right, let's rotate. That's 360. And if I go 180 more, that would be 540. If I went all the way around to right about there, oh, I went a little too far, damn. 360. If I went all the way to right there, that would be 660 degrees, which is coterminal to this side. Right there. And the definition of trig says, I don't care how you rotate, I just need the x and the y of where you intersect the unit circle. Okay, so that was the building the understanding of the following fact. If you're bigger than a rotation, or actually even if you're smaller, the homework that you practiced coming into tonight was finding coterminal angles. Bro, find a coterminal angle. And then you just bang out the facts on that, right? And that's it for tonight. So 660 exceeds 360. Find coterminal angle. Uh, 660 minus 360 is 300 degrees. So now we just use our unit circle, facts at 300. I'm still going to write this, though. The question says 660 degrees. So I'm going to make sure I write sine of 660, but I'm using the 300. So I look at my 300. The y coordinate there is negative root 3 over 2. I'm answering the question. So I'm saying at that rotation, but I'm using the 300. Taking the x coordinate. And then I can take the y, the sine value, over the x, the cosine value. Multiply by 2, multiply by 2. And there's no reason to rationalize that. Leave this, this, and this. Reciprocate. We get negative 2 over root 3 and rationalize. Take your secant, which just says reciprocate, and we're done. Lastly, cotangent. Reciprocate. -1 over √3. Rationalize. And that's how we kind of take the concepts together. I literally have 2 minutes more to do, and we're still going to get out a little bit early. Right. Being successful here means knowing your unit circle. I've said that now at least 5 times tonight, so you really got to do something. And if you put it off to last minute, that's not something you should be doing, right? So I've already encouraged you tonight, not tomorrow, tonight, learn 30, 45, and 60. Just quadrant 1, like bing, bing, bing. You're driving home tonight, say 45, pi over 4 radians, √2 over 2, √2 over 2. Start easy. Start like we started. Then go 30, and then go 60. Say it to yourself. Draw it out. Do something. Here's where we're going to end. Quadrants. This is almost overkill, but I do have to go over it. There are 4 of them. 1, 2, 3, and 4. In quadrant 1, all the x values are positive. And guess what? Y is 2. And since I have green, and I don't feel like jumping between my clothes over there, what else is positive? Y in quadrant 2 and x in quadrant 4. It's common sense, not because I'm telling you that. Literally over here, y's are positive and x's are negative. Down here, they're both negative. Over here, only x is positive. The rest of these are negatives. And why is any of this important? Because after we did the unit circle, I gave the stronger definition of the trig functions, which I said, sine is y over r. One last thing. What have our radius been? 1, which is a positive number. Yes? Yeah. So we have in quadrant 1, the y coordinates are positive over a positive radius. Sine is positive. X over the radius is positive. Y over x is positive. In quadrant 1, all the trig functions are positive. In quadrant 2, we're going to talk them out really quick. Sine is y. Sine is positive. Cosine is negative because it's the x. Tangent is y over x. A positive divided by a negative is negative. So who is positive in quadrant 2? The sine. And by the way, so I make a little note here, and it's reciprocal. But I'm stressing the sine for a reason. Next, in quadrant 3, a negative over a positive radius. Sine is negative, cosine is negative, but wait a minute, tangent, a negative over a negative is positive. So tangent is the only trig function that would ever be positive, and it's reciprocal cotangent. And you can convince yourself after this that cosine, and by the way, cosecant, is. Why did I go over that with you? Has anyone heard of all students take calculus? Some of us are shading yes, some of us say, no, I never heard that. All students take calculus. That whole chart can be summarized like that. What's up?
You put cosecant twice.
Yeah, I did, didn't I? Secant. And it's reciprocal. Thank you. So here's the facts, because they're literally facts. Boom. Here's a shortcut. This is what I wanted to build. From now on, I'm only going to use this when we need it. And here's the last question of the night. It looks like a scary question. But it says, if tan is less than 0, what kind of numbers are less than 0? Negative numbers. So from this sentence right here, it's saying tan's negative. Guess what? Everyone's positive in quadrant 1, so it's not there. And tangent is positive in quadrant 3. So we're not there. And the second clue, I like this, like detective work. I feel like a detective. Okay, you're free to go. And what else do we know? Sine is positive. Bro, only cosine is positive here. So now we know that this has to be in quadrant 2. I'll see you guys on Wednesday. There is a new homework. You should be able to complete all but the last question. That's okay. We'll pick up with a smidge. But if you're putting off homework, you should not putting off printing out some unit circles, saying your facts, and all those things. And no test this week. Sorry for all that confusion. I really do apologize. Next week, as officially stated. And it's only on trigonometry.
Before you shut that off, did I see you left out of the beginning?
So which?
Just
I ended up erasing a lot of it, but it's not that important. What's more important is the front side. That's like the building of that side. That's the most important side. Yep. See you guys.